Morning Algebra 2. So now we're going to move on to combinations. Okay, so on Monday or Tuesday, you should have listened to our lesson on permutations, done a little homework. Combinations are similar in the sense that they're a way for us to decide how many different options there are for a certain scenario, but this is a scenario where order does not matter. So with permutations, remember, order did matter. With a combination, we're just saying, hey, pretty much if we chose two different numbers, or maybe let's say three different numbers, and we chose an 8, an 8, and a 2, that would be the same thing as doing a 2, an 8, and an 8. Order doesn't matter as long as we have that same combination. So that means we're going to have less possible scenarios. So this is what our formula looks like when we have a combination. So we have n factorial over r factorial times n minus r factorial. Okay? An important little shortcut here is that if we have a combination where the number of total objects and the number we're using for our arrangement are the same, then there's only going to be one option there. Okay? So the way this is written is we have n combination r. Okay, so let's check out a few examples. So starting off, we have Natalie has 16 close friends. How many ways can she choose 5 to be bridesmaids in her wedding? Okay, so in this scenario, we're going to have 16 total options, okay? And then we're choosing 5 of those options, and we're just going to decide how many different ways we can choose 5. But remember, the order of those 5 doesn't matter. We're just choosing 5 of them. Now, it's not like first, second, third, fourth, or fifth, or anything like that. So to plug this guy in, we would do 16 factorial over 5 factorial times 16 minus 5 factorial. Right? So you'd be able to put that in your calculator. Right? So remember, if you don't have a graphing calculator and you don't want to do the work that you'd have to do for that, instead you can just go ahead to google.com and type in calculator. I'm going to do that right now so I can show you. And what you'll see there is, let's see, make sure you guys see it. See that little X with the exclamation point? That's the factorial for the Google calculator. So I do 16 factorial. Hopefully you guys can see that pretty well. Divided by, and then in parentheses, I'm going to do 5 factorial. And also 16 minus 5 factorial, that's going to be 11 factorial, right? So this is what I put in Google Calculator there, right? And then when I press enter or equals, I get 4,368. So I'm not going to do that for every single problem. That was just to show you what you should get when you're using the Google Calculator there. All right, so that's the number of options we have for this guy. So let's try a couple others. There are 24 students in Kyle's kindergarten class. How many ways can he choose 8 to attend his birthday party? So we have 24 total. This is a combination because the order of those 8 doesn't matter, right? So we're going to do something like this. We're going to do 24 factorial over 8 factorial times 24 minus 8 factorial. I put all that in my calculator, and it looks like I get something like 735,471. That's how many options I would have. All right, for number 14, Abby is adopting kittens from the pet store. If there are 18 kittens, how many ways can she choose 2? So the order doesn't matter here. She's just choosing 2, that's it. And we do 18 factorial over 2 factorial times 18 minus 2 factorial. And we put that in our calculator, and it looks like we get something like 153 different options. Right, so how about you guys try 15, 16? Please pause your video, and then when you unpause it, you can listen to these explanations here. So for 15, should have had 12 combination 4. And that was because we had 12 employees and we were choosing 4 of them for the Sunday evening shift. So I'm going to do 12 factorial over 4 factorial times 12 minus 4 factorial. And when I put that in my calc, I get something like 495. For number 16, you should have had 85 combination. We're choosing 3 to represent the team in a coin toss. Okay, so with this one, we should have 85 factorial over 3 factorial times 85 minus 3 factorial. You get something like 98,770 different options for that one. Okay, so what we're going to practice now is differentiating between a permutation and a combination. Okay, so remember, a permutation is an arrangement with a specific order, like first, second, third. You might have to do something in a specific order. And like if you're arranging letters, there's a first letter, a second letter, a third letter, and so on. A combination is a group with no specific order. So that's the difference between the two. So what we're going to do is we're going to determine whether the examples represent a permutation or a combination, and then we're going to solve. So it says, this first one says, how many ways can 4 candy bars be chosen from a store that sells 30 candy bars? So it looks like there's no order to those 4 candy bars. So this guy's going to be a combination. The way I would solve it, I'll do 30 different options, right? And I'm choosing 4 of them. So that's going to be 30 factorial over 4 factorial, and then 30 minus 4 factorial. And it looks like I get 27,405 options. Right, next one, it says, how many ways can 13 students line up for lunch? So in this one, order does matter, because when you're lining up, you might be first, second, third, and so on. So this guy's going to be a permutation, because remember, that's where an arrangement with a specific order. And we have 13 people, 13 students, and we're seeing how an arrangement of all of them can be lined up for lunch. So remember, we have a little shortcut. When we have a permutation and these two values are the same, all we have to do is take the factorial of that guy. Right? So that one ends up being a big number here. We're going to get something like 6,227,000 and 20,800 different options. Right, and then here we have, how many ways can you make a 3-letter arrangement out of the letters in the word trapezoid? So right when you see that word arrangement, you should be thinking permutation. In this one, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 different letters, right? And then we're going to go ahead and do a permutation where we just choose 3. Right? So we're going to do 9 over, remember with permutations, this is just going to be 9 minus 3 factorial. So we got 9 factorial over 6 factorial. If you put that in your calc, you should get something like 504 different options there. Right. So let's jump to another one here. Let's see. Let's go all the way down to 11, just to give you guys a little taste of that trick we learned yesterday. So this says, how many different 12-letter arrangements can be made using the letters in the word Indianapolis? Okay, so in this scenario, we're doing an arrangement, so that's a permutation. But remember, if you have some repetition, that's going to affect the number of different options you have. So in this one, let's count how many letters we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 to choose from. And we are choosing 12 for our arrangement, right? So up top, we're going to have 12 factorial. This one, we can't do what we did earlier when we had 13 permutation 13 because we have some repetition here. See how we have 1, 2, 3 i's? So we have to divide this guy by 3 factorial. Right? And then we also have some more repetition. It looks like we have 2 a's, so then we're going to have to do 2 factorial there. And we also have, let's see, we have 2 a's, 3 i's, and 2 n's it looks like, right? So that's another 2 factorial. So we're going to take our 12 factorial and divide it by 3 factorial, 2 factorial, and another 2 factorial. And that gives us something like this: 19,958,400. Right? So now we have permutations and combinations. You should have done numbers 1 through 6 before. Now what I want you guys to do is, let's do 7 through 20, and we'll just do the odds. 7 through 20 odds. Right? There's also a quiz available for you, so make sure you get that done. I hope you guys have a great week.